Hello, this is Sriraj Gaglani. I'm Chief Marketing and Product Officer at Metaswitch, now a Microsoft company. Building and managing a carrier network leveraging the cloud has always been a daunting proposition. Unlike enterprise software, many carrier voice services and network functions tend to be long-lived, have very high reliability requirements, and need to bridge legacy requirements with generational roadmap planning. Our partnership with public cloud vendors like Microsoft Azure have led to some key learnings and development of initial use cases that are now in trial development with large early adopter carriers and offer some valuable learnings and a viable path to running their network services in the cloud. In the process, these forward-thinking customers will benefit from cloud economics to reduce their total cost of ownership, along with developmental agility and a global footprint to launch new services for their customers quickly and economically. I'd like you to join me in exploring how Azure for Operators and Metaswitch are coming together to solve for these initial use cases and leverage these references to migrate your voice services to the cloud. Before we get into the detailed topic, let's talk briefly about Azure for Operators. Our aim is to make Azure far and away the best public cloud environment for hosting telco network functions. The key to this lies in the words here, built on a foundation of telco DNA. We know that telco network functions are different from web-scale applications. They have their own rather specific needs, and these needs are generally not well understood by the hyperscalers. What Microsoft has done by acquiring Metaswitch and Affirmed is to bring into the organization hundreds of network software specialists who have been living and breathing carrier networking for most of their careers. This know-how makes Microsoft unique amongst the hyperscalers, and it is the key to making Azure the go-to public cloud for telco network functions. Now let's talk about why carriers should care. Most of them have learned by now that building and operating clouds is really, really hard and expensive. Azure has massive economies of scale in its favor, and this scale includes a bunch of built-in platform capabilities, such as artificial intelligence and machine learning, that carriers can leverage to optimize and automate their network services. We also understand that not every telco network function naturally belongs in public cloud. So making hybrid cloud operate seamlessly is hugely important to us. With 5G particularly, there are lots of opportunities for new service revenues. But many of these depend on a cloud-based application development and hosting environment that is super friendly to developers. And Azure certainly ticks that box. Finally, Azure is trusted to host mission-critical applications by a huge majority of Fortune 500 businesses. And we understand just how important that trust is to carriers. A little about Metaswitch, now a division of Microsoft. We have long been recognized as the cloud-native pioneers in telecom. We began building network functions for virtualized environments in 2010 and cloud infrastructure in 2012, at least 3 to 4 years ahead of the market. But that's not when or where we started. We have been building software-only solutions for carriers, starting with carrier VoIP products in the 90s, before focusing on the carrier cloud, and now have over 900 employees with a global customer base of over 700 service providers. We are committed to writing better software that adheres to cloud-native design principles, which we believe will ultimately provide the lowest possible total cost of ownership through efficient hardware utilization and automated operational capabilities. We are the only major supplier to carriers that has a full breadth of carrier voice and unified communication solutions that can be deployed on standardized virtual and cloud offerings. Our disruptive mobile native approach is driving growth in both the mobile and the UC markets. We have also developed highly innovative technology and products for the 5G and edge networking market that allows us to deliver very high performance and small footprint solutions for our customers. We have a strong reputation for product quality and customer loyalty, which has everything to do with the quality of the people we hire, our culture for engineering excellence, and our commitment to doing what we say we will do. We are equally committed to our customers, and one of the achievements that we are most proud of is that we have the industry's highest net promoter scores. Much has been discussed about the cloud being an end destination for carrier networks, but the path to getting there requires a determined hunt for finding the right use cases, high return business cases, and dedicated investment in engineering and joint development to making these early transformations a success, to develop the confidence and experience to do more. Voice is the ubiquitous service offered by carriers to their customers and is a leading candidate for migration to the cloud based on economic pressures and realities. For today's talk, we are going to focus on how the combination of Metaswitch's carrier voice products with Azure for Operators enables carriers to start the journey of migrating their voice networks to the cloud. As we all know, voice services are a lifeline for many customers and provide ubiquity for telephony subscribers around the globe. Designed for high availability and service continuity, these common communications offerings deliver quality and reliability unmatched by over-the-top offerings. But maintaining and evolving these many solutions as they move through the service adoption lifecycle, coupled with continued decline of revenue for voice, demands the flexibility and modern operational business models only available with the adoption of cloud architectures and network functions. Communication service providers have now started the journey to convert the infrastructures underpinning their most critical services to host these established offerings. Over the next few slides, I'm going to present 3 use cases describing how pioneering hybrid cloud architectures can cost-effectively power what can be considered these trailing edge applications, bringing new innovation and breathing new life into these trusted and mandatory telephony services. The experience of these migrations and the realized benefits in cost and agility are going to be foundational. We see a large number of existing products and architectures come end of life over the next few years, and the blueprints we are creating for these early migrations will show the path to the last migration ever as these solutions move to the cloud. Cloudifying these services will also bring the benefit of creating options for new services and capabilities that were previously not possible in previous appliance-based architectures. Let's start with voicemail. Why would we ever consider replacing a service considered to be in decline? Consider the answer in 2 parts. First, why replace the voicemail platform itself? And secondly, why migrate it to Azure? The answer to the first question on why replace is pretty straightforward. The existing system is coming end of life, with support being extended year on year at increasing cost. Because it's based on legacy code base, it is becoming harder to maintain, bringing 2 key issues. First, it's vulnerable to security exploits and fixes for them are harder to get. Secondly, the APIs to the visual voicemail apps can be changed by handset vendors, needing changes to the voicemail system. Either of these brings an increasing risk over time to disruption of service. Finally, despite its declining usage, it's considered a critical service, so it must continue to be offered to customers. So there are strong drivers for change. Clearly, a new system is no longer end of life and can be built to be geo-redundant in any computing environment. Why then choose the particular course of deploying a replacement system in Azure? There is an operator-wide desire to move to cloud delivery of network infrastructure and services delivered to end users to drive efficiency, consistency, and bring innovation across the whole business. So that means private or public cloud, this is a generational decision to replace voicemail, and it makes perfect sense to consider cloudification when end-of-life events show up. Public cloud deployment offers a predictable cost model where pricing is related to utilization of the service. And finally, voicemail is an important service, an unavoidable one, but not the critical voice infrastructure itself. And with visual voicemail dominating as the way users get their messages, it has similarities to the web-based applications that are routinely delivered from the cloud. So it's an obvious first step for moving operator workloads into the cloud as the carrier starts their journey of building their experience with cloud migrations. This particular voicemail replacement example is with a cloud-based service for a project for a tier 1 mobile operator that has more than 100 million fixed and mobile subscribers. Their existing voicemail service has around 65 million subscribers, and the target is to grow that to about 90 million. While voicemail is an unglamorous service, it's an essential one. Table stakes for mobile phone users, still used by very many of them, and they expect it to just work. And to keep working the way it works today. So the challenge is to replace the existing system with a new one in a way that causes minimum disruption, ideally none at all, to the users of the service. Any change risks prompting support calls from confused users, and with a large user base, this could soon become a lot of calls, which costs a lot of money to deal with. So seamless migration from the user's point of view was critical. That means taking across the user's settings, greetings, and messages, and making the new system look, feel, and sound as near as possible, exactly like the old one. This is a particular challenge given the very wide range of handset types out there, including very old iPhones and Blackberries running old versions of visual voicemail. There are also challenges behind the scenes too. Migrating 65 million subscribers is a lengthy process. So the old and new systems need to exist for a long period, many months at a minimum. During that time, any given subscriber could be on either the old or the new system. And so there's a complicated coordination job to ensure that calls go to the right system, users' details and messages get migrated at the right time, and the transition of any user from one to the other impacts that user's service as little as possible. There's also a range of back office IT systems in operations, provisioning, and billing that are well entrenched and expensive to change. So the new system has to be designed to fit into this environment with as little change as possible. So how did we do it and what does it look like? Critically, the core of the service is deployed in Azure. The vast bulk of the workload is done in native containers with some virtual machines in certain areas, which is a pragmatic decision to maximize overall project efficiency by not forcing containerization where it wasn't critical or necessary. At the same time, some things have been retained in the operator's network. The voice over IP core network, for example, is well entrenched, as are the elements providing connectivity with the visual voicemail applications, the legacy mobile network, and the back office systems referred to earlier. Looking under the hood then, a key aim was to leverage the cloud services provided by Azure as much as possible, to use whatever we could off the shelf, and hence gain the benefit of the experience and hardening of these things and the predictable cost model mentioned previously. Obviously, this included the compute, block storage, and network elements that are fundamentals of the cloud, but it went a long way beyond that to include other infrastructure supporting service delivery, such as the blob store for voicemail audio and authorization and authentication services. Use of such services is expected to result in significant cost savings compared with private cloud. DNS is worth a particular mention. It is hard to get right at operator scale, but it's fundamental to how Azure works. And so the Azure service is really solid. We have also integrated with Azure's monitoring capabilities and leveraged the deployment pipeline and orchestration, as well as the automation tools to gain maximum benefit of these standard operational elements. The service has been split across multiple regions and availability zones to gain the benefit of resilience and meet the required standards of geo-redundancy and carrier-grade availability. Some adaptation of the voicemail service has been needed. While the original design was cloud-native from the ground up, deployment in public cloud brings important changes, such as the zero trust model in which the application must ensure its own security. This is particularly true of operator workloads, as carriers guard their reputations and don't lightly outsource their core services to third parties. This has meant encryption of all APIs and interactions between components, as well as signaling and media flows. Upgrades are also worth specific mention. Rather than upgrade containers of virtual machines in place, the cloud model is to deploy up-level versions and see if they work with some fraction of traffic, and then cut over and quiesce the old versions. This project is underway, and while not completed yet, we already have a few critical proof points for delivering this solution. We did an initial proof of concept of the software in Azure very rapidly some months ago. Now that the project is properly underway, we delivered working product code containerized in Azure for initial integration and testing within a very few weeks of signing. We expect the service to be made generally available by this carrier next summer, with cutover from the existing legacy systems to start soon after. If you have voicemail systems approaching end of life and require replacement, we encourage you to leverage our experience and this cloud-based solution for your future needs. The second use case we will discuss now is the challenge of operators supporting their enterprise customers with a trusted managed voice service globally. This customer is a globally respected Tier 1 multi-play customer, over 100 years of telecoms experience. They've been at the forefront of managing global voice services and have over 20 years of experience developing IP networks. They are already delivering billions of minutes of managed voice services every month for multinational corporations using Metaswitch products within that solution today. These managed voice services include SIP trunking, call handling services such as call screening and other VPN services, as well as call routing services to correctly route inbound calls to the right office. However, continued growth in their success was creating some challenges. For example, responding to demand in hundreds of countries around the world while keeping control of operational complexity. Another example is of demand that cannot be satisfied quickly enough if they needed to first commission service infrastructure in each location before they could provision new voice services. How to replicate the highly customized services already being used by their existing customers to keep them satisfied and to defend their competitive advantage against over-the-top options. And finally, how to enhance their service offering to extend their stickiness and get more share of wallet from their customers. We have found the solution for this customer by combining the global footprint of Azure with the Metaswitch Rhino interworking gateway function. Rhino is a powerful open telecom platform that is used for customizing call handling logic by more than 70 mobile, wireline, and converged operators around the world, including this customer. The flexibility of the Rhino platform has enabled our customer to develop a uniquely differentiated solution that addresses the corporate customer's bespoke needs and give the network operator the ability to design for the needs of a global distributed telecoms application. Azure provides infrastructure that already exists around the world, ready to expand into. And it's the same the world over. So the expansion process is already well known and easily replicable. Reacting to market demand now is both faster and simpler. Placing Rhino in these Azure data centers, local to the customers, produces faster call setup times and means that routing decisions taken before calls are hauled into a central site, provides more optimal routing, shorter path length, and shorter round-trip times, which ultimately reduces transmission costs and improves the customer experience. And to cap it all, the operator can be confident in the solution because both the network entities and the cloud infrastructure are being delivered from the same partner. First, the new solution would need a communication services platform that would enable them to recreate exact replicas of the existing services. This platform would then also need to provide the capability for further service innovation. So we provided Metaswitch Rhino Platform, a communication services platform delivering hundreds of different use cases with multiple operators around the world. Unlike traditional solutions that require expensive change requests to be raised with the vendor, because Rhino is open, the operator has multiple options for potential developers that can be used for customization services. Some use system integrator partners, some tap into the wider ecosystem of developers, many of whom have off-the-shelf applications ready to run on Rhino today. Some operators choose to have Metaswitch help with developments. Some have internal development teams, and some fully embrace the choice they have by selecting their development option on a case-by-case basis. In this case study, the customer had its own development resources that would replace and replicate the existing applications and innovate new solutions on Rhino. In this way, existing customers would continue to have access to the same services, and they would benefit from the innovations the service provider would later bring to market. Just as importantly, however, by selecting Rhino, this customer was also able to address the changes of global scale out at speed. How do they do that? Because they can deploy Rhino on Azure. Azure provides the infrastructure that already exists, ready to expand into the world over. And so the expansion process is already known and is the same every time. By deploying Rhino on Azure, customer will have open service creation for highly customized call handling services and future innovation, and they can scale out across hundreds of countries without scaling up operational complexity, while scaling out fast enough to meet demand. To cap it all, the operator can be confident in the solution because both the Rhino platform and the cloud infrastructure are being delivered from one partner. This customer continues to experience strong demand and has expectations that traffic through Rhino on Azure will reach levels of tens of billions of minutes per month in the foreseeable future globally. Over time, the architecture will extend to take advantage of the Metaswitch perimeter session border controllers in the cloud as well to increase global service deployment agility. Our third example highlights another use case requiring global deployment of a voice interconnect network and service by a tier 1 carrier. This project is for the wholesale interconnect arm for the customer. It replaces their current deployment, which is made up of entirely physical systems comprising of proprietary hardware deployed in Europe, North America, and Southeast Asia. The replacement is a hybrid public-private deployment in Europe with public cloud points of presence in North America and Asia. This new deployment model has been designed to be managed with common interfaces across both the public and private clouds, so that despite the disaggregated nature of the deployment, it can all be managed and operated in the same way as the existing deployment. The use case here is largely for international calling. For example, a customer wants to make a call to a different country. The wholesale interconnect provider may be able to route to that country themselves, but more likely, they have contracts with other interconnect providers to route the traffic for them. Each of these contracts comes with different prices, capacities, and service level agreements. So it's important for the operator to be able to intelligently route traffic, which is achieved by the use of a SIP routing engine, and be able to monitor and bill for the level of service they are being given and are giving. This means that there is a strong focus on monitoring and billing for this project. Their existing network uses a soft switch to achieve the key operations in the network, such as routing, billing, and making announcements. For example, to warn users that they're about to make a costly international call. Which brings us to the original driver for this project. Not surprisingly, their existing platform is going end of life. A perfect reason to visit cloud migration as a strategic option. The wholesale market for interconnect is highly commoditized with very tight margins. As such, the operator was keen that any network replacement would ensure the future profitability and viability of the business. Another generational decision that favors consideration of the cloud due to its predictable pricing models. Here is where the ability to run the perimeter SBC in public clouds comes to the fore. Public clouds offer the operator the opportunity to spin up points of presence almost anywhere of the world without a large outlay in setting up a data center in the desired destination. This means that the operator can widen their offering to their customers by being able to provide interconnect to a greater number of regions. The other key advantage of public cloud for this operator was to allow them to be able to scale the capacity of their network with demand. This had been discussed before in the context of migrating to a private cloud-only model, but the fact that they would have to purchase or reserve the underlying compute resources in the private cloud meant that any savings were not of the same scale that could be achieved by having this elastic capacity in the public cloud. So now we have a hybrid solution where the customer can leverage their existing private cloud investments and presence for average local capacity and use the public cloud for burst capacity more globally. This operator has chosen to deploy a mix of public and private clouds to implement their solution. The private cloud is only deployed in the operator's local country, where they have already invested heavily in private cloud infrastructure for their national network. Therefore, it was sensible for them to run their minimal deployment there for easier integration with the national network. However, to ensure that the deployment could scale with demand both over time as the business grows and for short bursts such as New Year's Eve or Mother's Day, the operator has chosen to deploy the SBCs in the public cloud in the same region. Traffic reaches this public cloud through Metaswitch's secure distribution engine, which is deployed in the private cloud and is the entry and exit point for all signaling traffic in Europe. This secure distribution engine distributes traffic to the session border controllers deployed in both the public and private clouds in a configurable ratio. This means that the usage of the private cloud session border controllers can be maximized while ensuring that there's no risk to service, as any increase in traffic flow can be automatically sent to the public cloud. Beyond the operator's home country, All foreign points of presence, which were previously deployed in privately owned data centers, are now replaced with public cloud deployments. This means that new hardware does not have to be purchased for these sites, and the management costs are delegated to the public cloud provider. In future plans, this will allow the operator to create new points of presence around the world with relative ease and very low startup cost. These foreign points of presence are crucial to their business as they mean that more geographically local calls can be routed in the local geography. This reduces bandwidth costs and provides better latency and quality of service. All elements in the deployment feed into a common monitoring solution, which is the Metaswitch Simon solution, which allows the operator to continue to manage the network in the same way as they do today, despite the fact that multiple clouds are now involved. So these three use cases have demonstrated the viability of delivering some of the most prominent, recognized, and utilized telephony service offerings by Tier 1 carriers. The key to them all is a foundation of well-engineered cloud-native network functions that make the most efficient use of the underlying public cloud infrastructure, while employing orchestration and automation techniques to minimize operational touchpoints. Only then can we deliver a viable alternative to legacy service offerings which meet target business models while providing a platform from which to launch a rich suite of new communications features and functionality. If you have generational migration decisions in front of you that you need to make that would benefit from a cloud approach, or have a need to deploy new services with a global footprint or hybrid cloud architectures, we would love to hear from you. In fact, we have made a proof of concept of our Perimeter Session Border Controller available on Azure specifically to allow our carrier customers to start experimenting with various use cases and start a dialogue on their specific problems that we can start evaluating for cloud migration fit. Thank you very much.